Alright guys, so today we're going to be talking about alkene halogenation. And essentially what that is that when we have an alkene, we're going to react it with a halogen diatomic, which just means two of a halogen, and we're going to get a halogen added on either end of our carbon chain. So in organic chemistry, the two most popular elements that we use are either chlorine or bromine. Now for the sake of the example, we'll just work with bromine, and that will show us our complete reaction and mechanism. So here is the mechanism as follows. Okay, so first what we can do is we can draw in our alkene, and then we can bring in our bromine. So we'll draw our bromine like this. We'll draw our lone pairs in as well. And so now what's going to happen is that there's going to be a 3 curved arrow step. So first what's going to happen is that the alkene is going to grab the bromine from one side. Our lone pair is going to grab or form a bond to a carbon on the other side. And then the bond between both bromines is going to break. We're going to move those electrons onto the top bromine right there. So now what we have is a little bit of a different structure in which our bromine is forming 2 bonds and has a positive charge. That's because it only has 2 lone pairs. So now what happens is that we're going to bring in our other bromine, the one that we broke off earlier, and that's going to attack one of our carbons. Now it doesn't matter what side we attack because both sides of our carbon chain are going to have a bromine each. So we can attack this side and break our bond, and what we'll get is our carbon bond still there, and our bromines on the other side. So now we have a little bit of an issue and something we can fix pretty easily, and that's where we need to focus on stereochemistry, which basically means just the placement and the geometry of where our atoms are in a molecule. So in this specific reaction for alkene halogenation, our bromines need to be anti to each other, which just means that they need to be on opposite planes or 180 degrees away. So all we need to do is essentially we would rotate these 3 atoms, our bromine, our hydrogen, and our methyl group, and we would basically have a new molecule, or the same molecule essentially, that looks like this, where our bromine is on top and our other bromine's on the bottom. So it's a pretty simple mechanism. We just need to pay attention to how we order our bromines at the final step to get a correct end product. And other than that, that's the complete reaction and mechanism for alkene halogenation. Have fun with it. I hope this helps, and I'll see you guys in the next video.